Students, good morning. Welcome to the chemistry class. In this class, we will discuss about the chapter the language of the chemistry, in which we will discuss about what is the symbol. So the term symbol represents a short form of an element. The qualitative and quantitative meaning of the term symbol. Okay, a symbol represents a specific element or one atom of the elements. For example, the symbol of sulfur is capital S. Capital S is basically represented by symbol sulfur. A symbol also represents the weight of the element equal to its atomic weight. That is, it represents how many times of an atom is heavier than one atomic mass unit, which is defined as 1 by 12th of the mass of the carbon. So, symbol represents a specific letter or element for a particular element. Okay, so introduction to concept of a single. So in 1807, John Dalton suggested figurative symbol of atoms of elements. For example of figurative symbols, for example oxygen, uh, for oxygen like this, hydrogen like this, sulfur like this, and nitrogen like this. So if you will see the representation of the molecule in which these symbols combined with each other and form the compound. So for ammonia, you can see that there is one one nitrogen and three hydrogens are attached because the formula of ammonia is NH3. And for sulfur dioxide, SO2, S is at the center and 2O on both sides. Okay, hydrogen sulfide like that. The above methods was combustion and later abandoned. In 1814, new scientist Berzelius suggested a simple terms of representing elements with symbol. He put forward certain points of presentation. First point is, in most cases the first letter of name of an element was taken as the symbol for the elements and written as in capital letter. For example, for carbon, the symbol first letter of carbon is C, so the symbol of carbon will be C. Sulfur, the symbol will be S because it is the first letter of the term sulfur. So it was the first point. In second case, in case where the first letter is already adopted, the initial letter in capital together with the small letter from its name were used. If first letter of the terms is already used, then we will take the second letter with win second letter in small letter with the symbol. For example, calcium. So calcium, for calcium it should be C, but C is already used in case of carbon, so we cannot take only C. Now we will take C with A, so the symbol of calcium will be Ca. Like that, silicon, it will be Si. Okay, so the symbol for some metals were derived from their Latin names: copper, cuprum, iron, ferrum, potassium, gallium, gold, aurum, silver, argentum, lead, plumbum, sodium, natrium, and mercury, hydrogonium. Okay, so these are the Latin words from where the name of these symbols has been come. Okay, now come to the valency, radicals, and chemical formula. So the number of hydrogen atom which can combine with or displace one atom of the elements are radical. So it so as to form compound. So for a particular element, how many number of hydrogen can be attached will known as the valency of that of particular elements. So the valency of all metals and hydrogens, the valency of all non-metal and group of non-metals. So valency of all metals and hydrogen is considered as positive, and for non-metals it will take as a negative. So combining atom product formed and valency. For example, one atom of hydrogen and one atom of chlorine. So product form will be hydrogen chloride, and chlorine contains valency of 1. Like that, two atom of hydrogen and one atom of oxygen. So water will form and the valency of oxygen is 2. and 3 atom of hydrogen, 1 atom of nitrogen. So the ammonia is formed and nitrogen has the valency of 3. So you can see that a particular elements, how many number of hydrogens are attached. If there will one hydrogen attached, then the valency of that element will be 1. If there will be two hydrogen will attach, then the valency will be 2, and if it will 3, then the valency will be 3. Okay, so you can see that the valencies depend upon at a particular element how many numbers of hydrogen get attached. Okay, so the valency of a metal is number of electrons lost per atom of the metal. So you can see that in case of metals, the valency can be calculated on the basis of number of electron released. For example, potassium can release one electron, so it will carry one positive charge and it will known as a univalent cation. For magnesium, it will release two electrons, lose two electrons, carry two positive charge and known as divalent cation. And aluminium can release three, so it will carry plus three charge and it will treated as a trivalent cation. In case of valency of non-metals, it will depend upon how many numbers of electron can accept by an non-metal. So chlorine can accept one electron, so it will carry one minus charge. It will also univalent. Sulfur minus 2 because it can get two electrons, and nitrogen 3, and because it can accept three electrons. So these are the valencies of metals and non-metals. Now come to the variable valency. So certain metals exhibit more than one valency, hence showing variable valency. Reason for exhibiting variable valency, what is the reason behind it? An atom of an element can sometimes loses more electrons than are present in its valence shell. So there are some metals which have the tendency that they can loses more than one electrons. So in that case, this show variable valency. Okay, so valence shell that is lose from penultimate, that is at last but one cell, and hence exhibit more than one or variable valency. For example, copper show two valencies, that is cuprous Cu plus 1 and cupric Cu2 plus. Okay, so copper atomic number 29 with electronic configuration 2 8 18 1. The outermost shell has 1 electrons and the penultimate shell contains 18 electrons. However, the penultimate shell has not attained the stability and one or more electrons sometimes jumps to the outermost shell, thereby increasing the valency. Hence, the atom of new configuration, that is 28172, is formed. Therefore, the copper exhibit these two valencies. Okay, there are some other elements are present here which can show variable valencies. Okay, now come to the radicals. So radical is a group of atom of elements that behave like a single unit and show a valency. So radical is a group of atom. It may be group of atom or it may be a single atom, but it always contains a charge, or you can say that a valency. Radicals are of two type: positive radicals, for example ammonium, carry one positive charge, and negative radicals, for example hydroxide, carry one minus charge. Okay, so the chemical, what is the chemical formula? What is the chemical formula? A molecule of the substance, that is element or compound, could be represented by the symbol, and that is known as the chemical formula. An element is referred to a monobasic when it exists as a single atom and represented by a single symbol of that elements. For example, sodium, potassium, hydrogen, oxygen, these are the monobasic acids. Monobasic um, monobasic elements. When an element exists in as a molecule, a number of representing its atomicity is written as the subscript after the symbol of the elements, thereby representing its formula. Okay, so a compound contains whole number of atom of component elements, indicating that the elements are in chemical combination, therefore representing its molecular formula. A molecular formula also indicates the number of units of radicals present in a compound with the proper script outside the unit of the radical. Example, outside calcium hydroxide. So there are some terms. Elements are basically single units. For example, hydrogen, nitrogen, oxygen. So these are known as the elements. Now when an element exists in a molecule, number representing its atomicity, When two or more than two elements combine and form a molecule, then it is basically known as the atomicity. For example, hydrogen. In hydrogen gas, there are two hydrogen elements are present. So its atomicity will be 2. So it is represented as formula, and this is known as the atomicity. Now compound. So compound, as we know that when two or more than two elements are combined with each other and form a substance, that is known as the compound. And this compound is represented as a molecular formula. For example, calcium carbonate. Atom of calcium and carbon, an atom of oxygen. When these elements combine, then calcium carbonate is formed. A molecular formula also indicates the number of units of radical represent. In case of molecular formula tells us that in a molecule how many numbers of radicals are present, positive radicals or negative radicals. For example, in case of calcium hydroxide, there will be a Ca2 plus calcium positive radicals and OH 2OH minus. These are negative radicals will be present. Okay. Now come to the some examples here in which you can see that positive ions or radicals are present here and negative ions and radicals are present. Positive, for example, potassium carry 1 plus charge, sodium Na plus, lithium Li plus, hydrogen H plus, ammonium NH4 plus, and like negative valency, chloride Cl minus, chlorate ClO3 minus, hypochlorate ClO minus, bromide Br minus, iodide I minus. So you can see that here there are many radicals are present with their positive and negative charges. Okay. Now come to the compounds. Compounds. Okay. Thank you. Have a nice day.